everybody. Thank you for joining us today at PSConfEU in general and at my session on Entra Authentication 101 in particular. Before we get started, a big shout out and thank you to all of our sponsors. Without them, none of this would have been possible. Thank you. So, quick bit of thing about me. I'm Fred. Friedrich Weinmann, Cloud Solution Architect working at Microsoft. Used to be known as Premier Field Engineer, the role, but you know how the renaming thing happens. I'm doing some weird things other than PowerShell. Admittedly, most of that is also with PowerShell, so if you're interested about gaming mod release pipelines or building ebooks with PowerShell release pipelines, talk to me afterwards. I'm very open to that. And you can always reach out to me after this conference as well, either on Blue Sky or on Discord. I should be most responsive. Yeah. And there's a few resources if you want to look more, like where can you get Fred code. But today is not really about me, it's about Entra Authentication. So we're going to be talking about a few things. First of all, I'm going to significantly abbreviated quick context about how authentication evolved, so that we have a concept like what problems is Entra Authentication actually trying to solve. Then we get some hands-on, and then we try to cover most of those weird idiosyncrasies that happen when we're trying to delve deeper beyond Connect-MgGraph, and magic happens. And then we go into the details. So, how did it all begin? In the good old days, we had basic authentication. It's really simple. I've got a client, I've got a web server, and I'm sending my credentials over, and the web server decides this is good, this is not so good. What most attackers decided was this is very good. Every single web service was responsible for implementing their own authentication. How many forums or mini websites were hacked with databases that contained the password in clear text? They're for security concerns. So let's not do that anymore. So in the Microsoft world, we moved on to Active Directory and Kerberos authentication. In a highly simplified way, we have now a client computer who wants to talk with a web server. So they talk not with the web server, but with the domain controller. Hey, I really am Fred. I'm promising you I am. Password hash, certificate stuff. There's different options how we can provide the evidence to Active Directory. And Active Directory is now going to assign us a ticket with the information that's basically an entry ticket to the web server. And with that, we now send the ticket to the web server. So if an attacker compromises the web server, they have not our secrets, not our evidence, they only have that entry ticket to the web server, which usually is not enough to compromise us. Which is, by the way, one of the nice advantages of PowerShell remoting. We do the same thing. We only have the entry ticket to the WSMan service on the remote computer. So if you use domain admin to remote into a target machine, the attacker won't really get much out of it. That's great. This has a few significant problems right here. First of all, it assumes we have a web server, we have a client computer, and not a web service, some API, something, and an application that might not be on a client computer. It might be a runbook, it might be a function app, it might be somewhere, something. So this is very context-bound. The next problem is the only thing our identity and authentication system sees is like user X on machine Y is trying to access some kind of resource speaking the following protocol. That's all the information the identity system is ever going to have. And it's only going to be once, and if you then reuse the tickets for a long time, well, that's what we're doing. In other words, if you're now trying to track and monitor behavior, actions, we have to do this at every single web server end. And each service will have their own kind of monitoring, their own kind of logging, their own quality level of logging. If we're now trying to get a consolidated view of what's happening in our environment, that's a lot of work. And it's not made easier by the fact that, well, on the client computer, we don't know what application is running there and using those tickets. So your average user could just download some shareware software, run it on his computer, and if they don't need admin rights, well, that's just it. We might have complicated application hardening mechanisms to lock down our machines, but it's a real strong struggle. So, introducing Entra and OAuth authentication. The two are not a one-on-one link. You cannot do OAuth without Entra. You have an application now. The app is authenticating to Entra, getting some token, and then we're sending the token to the service. Again, I'm simplifying quite a few things here. But that's not a fundamental way, and we can now, at the Entra service, detect user logons for the specific service with the specific application. An attacker that now tries to con a user through a link to run some code for them, well, if they don't have an application already that exists in the tenant, has the necessary scope, so we'll be getting to that, they're kind of screwed. Doesn't mean attackers can't win. Doesn't mean that's a foolproof thing, but we get a lot better unified signals at the identity end. And we raised the barriers for, let's say, a script kiddie level of threat. So that's basically what we're looking at with Entra. And that means a few things for our code. So, time to switch back to good old PowerShell and see how bad I mangled things up the demo gods. I'm kind of missing a picture. That... Excellent. So, we start with the thing that we need an application. We could just run Connect-MgGraph and are in. How does that work? Well, Microsoft provided an application for the Graph SDK, for the Graph PowerShell thing. I select who I am. Yeah, great. And I'm now in, and I can now use graph commands. This is a first-party application that exists in every single tenant. Which also means, since it has the same application ID in every single tenant, every attacker knows that ID. And surprisingly enough, there are quite a few IT departments who don't like their attackers knowing their application IDs to do stuff. So they do a little portal setting and suddenly nobody's allowed to use it, and Connect-MgGraph doesn't work anymore outside of our beautiful lab environment. So, too bad. Time to set up our own application, because at the end of the day we will need our own applications for quite a few reasons. So, in the portal, I go to app registrations and register a new application, which I shall dub PSConfEU demo app. Now, for an admin perspective, there are a few options we can set up here, but we only ever need the first option, should only work in the current tenant. Other options are basically for software development companies. We don't need that. And register. That's it. I now have an application that can hopefully do things. The first thing is I'm going to write down the IDs, because without the application ID, I'm not going to get anywhere. I am also going to write down the tenant ID. The interactive user mode authentication flows don't literally need this. It's just still handy to have. We could instead provide the text organizations, then we get the pop-up and it will automatically select the tenant of the user account. So this is not enough. One of the key aspects that annoyed us with Active Directory is that essentially once you're logged in, you're running around as the user and can do everything that the user can do. Any app can do anything that the user is allowed to do. The This is something we limited slightly with something called user account control and running a software as administrator. But that only works on a local computer. If you do have any Active Directory rights, every single application can now read your Active Directory at the very least. Whether it needs to or not doesn't matter. In Entra, we say, okay, yeah, great. You need to declare what part of my permission set we actually want to use. And by default, that's nothing. Well, other than user.read, which is basically read your very own user information. Who are yourself? So I'm going to add a few more. And what we can see here is there's a large list of applications already offered for us. The biggest one up top is the one that most of us are probably going to use the most, Microsoft Graph, because that's all of the Office 365 information layer. So let's go there. And there's the first decision point, delegated or application. We will cover the details more a little bit later, but basically delegated, act as the user, application, traditional service account thing if you want like a scheduled task running unattended. There's more difference between that. And then there's a huge list of permissions, and I just want to get a list of all users and some rough data. So I pick user read basic all. So my application is supposed to get a list of users. What I also need is to interact a little bit with SharePoint. So let's add more permissions. And somewhere down here, there's SharePoint. Delegated permissions, and since my memory is lousy and I looked up the API documentation at some point, just what permissions do I need? All sites.read. There we are. And a second one, SharePoint delegated permissions, sites search all. So figuring out what permissions you need can be a bit of a chore. Let's hope for good API reference documentation. For Graph API, that's actually pretty good. For some of the other APIs, such as SharePoint, kind of depends on your luck. So I say I want all of these permissions. And now somebody needs to do something called grant admin consent. Everybody is supposed to, it's supposed to work for everybody. Some permissions are so deep that it's absolutely required. Other permissions or scopes are considered not critical enough, such as user read basic all, that every single user is allowed to consent for themselves individually. I'm just going to be the big bad admin and click on grant consent. Now there should be a green checkbox in a moment, and your application is good to go. Excellent. So we are connected, not yet, but we have everything set up. Our application is now good to go, I hope. Let's see. First of all, I'm trying to access Graph. And if I don't use the specific module for only that part, like Microsoft Graph, I need to tell Entra what do I want to work with, which we can do by clicking in the API permissions at the header and copying this thing. Whenever an API request for connection wants a resource, it's this. Adding it. And what I'm going to use now is a command called Connect-Entra service. This is a module of mine called Entra Auth, which is not specific to any particular service. Microsoft.Graph, of course, gives you only Graph tokens. AC.Accounts gives you Azure tokens. Connect Microsoft Teams is going to get you Teams tokens. But if you need an app that does multiple ones, you've either call each specific command or somehow you need to do your own connection. And Entra Auth is kind of a generic connect to whatever. it makes it a simple demonstration purpose without being specific to a single service. So, connecting, and I'm currently connecting as myself, as thread. And this is intentionally meant from an authentication mechanism to force an interactive user interaction. In this case, we are using the default authorization code flow. A browser window pops up, I select the account, and I'm in. Or not. Oops. We are not actually quite finished with configuring everything. So we can close that. And since the call doesn't recognize that it's hung, I need to Control-C, cancel it. Because what we still need to do under authentication, define how exactly we are allowing logging on. Without that, well, it's so nice. We've got an app registration there, and it's possibly going to do something at some point. And it's a very intuitive naming. We need to add a platform. And I've got my PowerShell script running on my machine. The usual one is mobile and desktop applications. And I need to provide a redirect URL, which is going to be an extremely secure one. It doesn't even have HTTPS. I'm going to redirect to localhost. There's a tech reason for that, because the browser window needs to redirect the logon token to my PowerShell console, and it's running on localhost. So, that's it. Let's try that again. Again, browser pop-up. I'm doing the pthread one. I am now connected. And I have a token. What you're seeing here is a processed object from my module. The actual access token looks like this. Not very user-friendly, but it's what the system expects. And if we ever need to troubleshoot this access token, there is a useful tool called jwt.ms. No matter where you get the token from, no matter what service you're trying to work with, the token format is always the same. And jwt.ms is a Microsoft Mini website which allows you to paste in the token, and the system will tell you the exact details of the token, what user you are, what scopes you have, somewhere in there. Yeah. It's all in there. So, we've got the token. So let's do a request, invoke REST method. The blankest way of doing things. I've got the full URI and want information on me. And I'm providing the authorization header, and I'm good. That's it for simple. I did a simple graph connect and did a graph request without any dependencies, just with the default box and Entra Auth. So, of course, I'm a bit lazy. So the header, why would I be building that on my own all the time? So I call it .getHeader, and that works. So we have now graph going. My app also needs to talk with SharePoint. So I've got this slightly unwieldy request that I need for that. Don't ask me how long I took for that one to make that to work. So store that, execute it. Oops. I got an error description, exception of type Microsoft.IdentityModel.tokens.audience URI validation failed exception was thrown. The specific exception that happens is kind of depends on the service. What's happening here? Any given token can only ever work against a single type of resource. Your access token you got for Graph can't work for Teams, can't work for SharePoint, can't work for Azure DevOps. I've got that processed, exactly what the audience is. We get some scopes out of it, which is nice. And now we need to connect to SharePoint. So we've got the API permissions, selecting SharePoint, copying that in there. Okay, I'm just going to have to remember to type the H. Connect to SharePoint, get a new prompt, confirm it. Yes, I'm connected. And I now have a SharePoint token. The audience is not always a nice little URL, but it works. And now I can do the SharePoint request, which gives me an useful response of the SharePoint site that I was looking for. Not every API works as convenient as the Graph API or as consistent. So, well, we need to dig down into what the hell do we get there. This is also not always a simple journey. And at some point, you figure out the obvious address you should have always been requesting. But that gives me the SharePoint site I was looking for. So, that's lots of UI interaction, confirming yes and everything. And every service, every application that works against Entra uses the same authentication mechanisms behind the scenes. But you're not authenticating to your Outlook every single hour. These access tokens, they are valid for 60 to 90 minutes. So how do you not need to re-authenticate Outlook all the time? There's something called refresh tokens. When I authenticate using the browser, I get 2 tokens in return. One of them is the access token for the actual requests, and the other one is something called a refresh token, which is valid for an ongoing time, and is used to get another access token when the old one expires. If you're implementing your authentication yourself, you have to implement that yourself. MgGraph, AZ accounts, and all the other tools handle that for you, which is one of the features of the Microsoft Services Authentication Library. It's useful. It has its pitfalls. I start a new console after the start of a new workday. I do Connect-MgGraph, and I'm not prompted for anything. I'm immediately logged in. How does that work? Well, somebody obviously cached our refresh token on disk. Now, what if I'm connected as global administrator? Now I've got a valid global administrator refresh token on my disk. There might be some concerns there. So, Entra Auth handles the refresh token for us as well. And we can use the refresh token to get a token for another service. So I can use the refresh token from Graph to get a new token for SharePoint if it's on the same application. There is no interaction, no browser pop-up, and if I do a script against multiple services and I handle the refresh token, I only need to bother the user once. Still works, still does the way too long request, and we still get the information. So far, the simple workflow that we're working with, the same is true for all of the Microsoft modules that interact with Entra. We do that authentication in some way. Which brings us back to the second part. In the portal, we did this grant admin consent. We now have here an app registration. What is actually the nature of an app registration? What does granting consent mean? And why do we need fairly high privileges to do so? So, when we deal with applications in Entra, we have a big problem. Somebody decided on the portal terminology, somebody else decided on the API terminology. So if you're trying to, okay, I can do this in the portal in way 1, and now I'm trying to do this in the API, well, good luck searching for that. There is no API concept of granting consent. Consent isn't a thing. At least not in Graph API in Entra. So, an app registration, and there's the enterprise application. There is a direct link there. And what is the app registration? The app registration is what the software developer knows about the app. When I add a scope under API permissions on the app registration. Every single person in the tenant can by default add more scopes and add more scope and add more scopes, and it's fine. Because this is the manifest, the software manifests. These are the rights that I want to have, that I'd like to have. Please give me those rights. Which is also why we need somebody to actually approve or disapprove. The enterprise application? The enterprise application is what your Entra tenant knows about the app. Who's allowed to use it? Who is allowed to authenticate with that? What actual scopes am I granting in opposite to what the app registration actually wants? Now, for the apps that we implement for our admin tasks, that's a one-to-one relationship. I create the app registration in my tenant, and I automatically also get the enterprise application. The same is not true for example, Microsoft first-party applications. The app registration for those exists only in the Microsoft tenant. But the enterprise application is duplicated to every single tenant. And if you're getting some software from a software vendor, and somebody first needs to approve that application for your tenant, well, they create the service principal or the enterprise application for that. And the API, Graph API, allows us all of the Entra actions. The app registration is called application. Yep, the app registration, not the enterprise application. If you want to interact with enterprise applications on the API layer, they're called service principals. Admittedly, service principal is a collection term for both enterprise applications and managed identities, which is the other fun friend that we have in the game. We'll be coming to that. So, here we are. And when we're now talking about consent, what really happens, I declare scopes in the app registrations. And by clicking on that consent button, I copy them over into a table on the enterprise application. Or on a dedicated table if it's a delegate one. And if you're talking at the API layer about application level scopes, things that we want our service account to be able to do, they're not called scopes, they're called app roles. So trying to figure out all of the API connections can be a bit of a puzzle there. So here's one problem that we encounter quite frequently. I've got a runbook automation account. I've got a scheduled task equivalent in Azure, and it has a managed identity. So I want to give that managed identity some rights in Azure. A managed identity is a kind of enterprise application. But there is no associated app registration. It's only a service principal. But when we use the portal, what we used to do is we configure the app registrations with the scope and click on Grant Consent. But there is no way for us to using the user interface to apply the same actual permissions to our managed identities. So what do we do by default, since we are kind of stuck there and we only have the user interface? I create an app registration, generate a certificate, put it in a key vault, grant the managed identity access to the key vault, because I don't need any scopes for that. And then my automation account can access the key vault to get a certificate to use the app registration. No, actually, enterprise application associated with the app registration to do the actual requests, which is clunky. We don't want to do that. And we will later look at how we can add scopes or permissions directly to a managed identity. So whenever we do the actual connection, we never connect through an app registration. We don't. We always connect through the enterprise application or the managed identity, in other words, through a service principal. So there are different ways we can do that. One of them we already saw, which is through the authorization code flow. I'm typing the connect command, a browser window pops up, and I select the account, do MFA, do FIDO2 keys, to comply with conditional access policies, and at some point I get my token. But there is this difference between application scopes and delegate scopes. Remember, whenever we assigned a scope in the API permissions, we had two options: delegate, application. In simple terms, application is meant for service accounts, where I need a certificate or a client ID or some other way to authenticate that. Or delegate, there's a human being in front and executing the authentication flow. There is a very non-subtle difference between delegate scopes and application scopes. A delegate scope is, I want to use this subset of permissions that the user has. Yes, the user could theoretically list all the groups in the tenant, but I only care about the users. For an application scope, that is a global privilege grant. Example, graph scope mail.send. If I do this as a delegate scope, I can send emails as myself. If I grant an application scope mail.send, I can send the email as anybody in the company, as the CEO, as the workers' council, as our lawyer. Great stuff. There are ways to constrain that. You might want to contact the Exchange team on that. They'll probably complain if you demand mail.send on application. But that, of course, also directly controls how sensitive you have to deal with the scopes. And it's also the reason why pretty much every single application scope requires global admin consent or application manager consent, which is the equivalent of global admin. So, on the application side, we have two default authentication flows other than managed identity. One of them is client secret, which is pretty simple. I go to the app, go to certificates and secrets, generate a secret, yes. And then important thread, I need to copy the value, not the secret ID. I usually default to the secret ID by accident. And then I'm wondering why I get access denied. So I've got a secret. Secret equals get clipboard, convert to secure string as plain text force. Now, quick spoiler, whatever you yes, typos are, of course, part of the course. A quick spoiler, PowerShell automatically generates a log file of everything you type. If you put in an API key or a secret into your console, that's in a clear text log file in your app data. So I'm using get clipboard here. And connect Entra service, client ID, tenant ID, client secret. Now, here's one thing about client secret. Different Microsoft modules implement this, how you parameterize this differently. Some of them might force you to create a credential object with the client ID as the account name. So the details on how it works might differ, but the end result is always the same. And then I'm going to just invoke Entra request users. And I get an, oh, access denied, because I didn't assign any application scopes. Fortunately, that is easily remedied. Add permission graph application user.read.all. Yep, add and admin consent. Now, the authenticating with the client ID is, if a client secret, is okay, but it's extremely risky. Since you now have the convenience of a plain text password that's essentially basic auth for service accounts, you might be tempted to put that into a script. Now, I'm quite active in the Microsoft internal PowerShell community, so if you get a service ticket and a supporter doesn't know enough PowerShell, which is like 99.9% of the supporters, they ask the community, and usually they sometimes give us access to some of the scripts supplied by the customers. So I've had global admin, I have Teams admin, Exchange admin, directory read-write all, and other things in plain text in the scripts provided. Please do not use client secrets. But it's an easy way to get a quick demo going. What we want to do is use client certificate. Important part here, we don't need a trusted verified certificate. It's simply enough to do a new self-signed certificate. We need a subject, which is cn equal PSConfEU. I need to provide a cert store location, which is cert current user. My go. Get raw cert data. And now we need to tell Entra that the certificate is valid, so I need to upload the public certificate, not the private key. The private key remains on my machine. So system.io.file, write all bytes. The haste makes waste thread, don't do it. And I'm writing the bytes. And if I don't do the typos, it should actually work. And in a portal under certificates and secrets, I switch to certificates, upload certificate, select the certificate, and that's it. We only need two things in order for certificate-based authentication to work. One, it needs to be still valid from a time. It must not have expired, and I need to have the correct private key. Everything else doesn't matter, but it's a trusted signer or not is not even considered. Okay. Comment from the content, even the expiration date does not matter. So even better. Or even more convenient, better. We might argue about that one. So that's it. And in case of Entra Auth, what we're doing is provide the certificate. We can provide that in different ways, certificate object, or we could just provide the subject, and it will take the latest subject available from any of the certificate store that has a private key and works that way. And that's it. Now, between client secret and certificate, there are very valid reasons to prefer certificate. I mean, okay, we are less tempted to put it in plain text into the script. That's nice. But there is also a very significant security concern here, because with the client secret, we literally send the client secret to Entra, which means it leaves our computer. With a client certificate, we sign the authentication request, and only the signed request leaves our computer, which means in case of certificate-based authentication, the secret never leaves our machine, which of course is a lot better. So that's it for application default authentication with the two methods that we usually use. On the delegate side, user side, you already saw the authorization code, so I'm not going to repeat that looking at the clock. There is also an alternative mode that I'm not going to iterate through, or at least postpone to later, which is device code. With device code, it tells us, go to this link, insert this key, and then do the authentication. The key reason why we have device code is if we need to use delegate authentication on a machine that does not have a graphical user interface. Imagine WSL. You just have a console. How are you going to open the browser on a console? The problem here is this is a lot more vulnerable to phishing if the attacker can get the user to open that link, insert the ID, and execute the authentication. With the authorization code that we already saw, the browser must happen on the same machine as the code is happening, which is a higher bar to pass. I have documentation on how to set this up with screenshot and everything. You get the link at the end of the session, so we'll probably not get to it, but if you still need it, there's a way. There is also conditional access policies available to prevent device code, which are fairly widely deployed by now. So device code is in most cases not going to work. There are a few more edge case authentication workflows we're not covering. Something like, hey, here's basic auth. Surprise, surprise, nobody wants that. So that's not going to happen. One last one that we are seeing that is a certain point of confusion available is the good old or good new Connect-AZ account. And suddenly I get this pop-up window. This is called the Web Account Manager. And it is the latest and greatest way to do delegate authentication. What's happening here is that our PowerShell console is triggering a Windows API to show us that user interface. And that refresh token is actually never in our hands. We only get the final access token, which makes it a lot harder to exfiltrate the refresh token and have the attacker use it on another machine if we never actually touch the refresh token. So when you can, WAM is great. From personal implementation perspective, I can tell implementing WAM Web Account Manager authentication is a bit of a pain. But you don't have to. Microsoft authentication libraries offer that for you. So use the official libraries and you're done with that. So last one, and the one most of you are probably waiting for. I've got a managed identity, a runbook, or a function app, and I want to directly authorize that function app, that identity. I've got one prepared. It's going to authenticate and then offer a way to request user information. We've got the function URL. Same thing, we get an API key. In this case, we're not going to cover all of the intricacy of function apps here. It's more of a proof of concept for the permissions. I can try to run this. URL equals get clipboard. Again, I've got an API key here, so I'm not going to paste this anywhere where people see, and especially my logs is seeing it. Invoke REST method URL, and hopefully something is happening. We can see that here in the file system logs, which we might need to reconnect. And it's going to try something. Problem is, I didn't yet assign an identity, so the authentication as an identity isn't going to work. So, identity is fortunately a simple thing to do. It's a simple toggle here. If you're setting up an automation account, that toggle is automatically set for you, and you don't have to deal with this. I want to do that. Takes a little bit. There we are. Going to get users again. It switches is by default app insights. We don't care about app insights for test functions. I go to file system based log. Gives me a warning. Yes, I want to do this. And now it all works. The problem is I managed to screw things up. So that one is on me. The function app is not going to work because fixing that is going to take more time than we have. But I can prove the permission thing because I have another module, Entra Auth.graph.application, that basically implements the portal experience in the command line. So suddenly there is a grant consent command there. And I'm going to need to switch authentication here, connect, Entra, service, client ID, graph. I'm using the default graph SDK client ID here. Yes. Good. And now I can assign to the identity I created the scope user read all for the resource Microsoft Graph. I could also have used the graph URL we've seen before. Both work. And demo gods, I love you. No better timing for that. Okay, I managed to screw up my demo at the last edge. This command should have done it. I'll look that up, but we can try whether I simply messed it up on the resource URL and use the one we had before, which is Graphon, and give that one last try. The good old, but it all worked 2 hours ago. So anyway, that's basically the part that's supposed to do. As soon as we run this successfully, or the API behind that, it is going to actually apply the scopes to the enterprise, to the service principal of our managed identity, which we can also see in the portal if we don't look at app registrations, but enterprise applications, and remove this default filter. We don't see managed identities in the enterprise application portal, which is basically the service principal portal, because the filters automatically for enterprise applications. So if I'm looking for PSConfEU, there's my PSConfEU demo managed by Microsoft. And if we look at it, there's the permissions tab, and if the command had run, we could verify that the scopes are on this page. All right, I already extended beyond the time. Thank you for your patience with me. I'd love to say questions. The next speaker is gonna kick my ass if I'd extend this more. So if you have any follow-up questions on that, you know where to find me, and I'm always happy to talk more about this, and I'll also sit down and fix that demo. Thank you. Oh, and right, before I forget that last part, if you want all the links and resources, you might want to do a quick photo of that one. That has all the resources of everything we saw today, including for all of the setups in the portal, screenshot by screenshot guidance, if you want to make somebody else set up applications and configure them for the authentication flows. Thank you.